How do we expand? How do we expand this expression? Now, when I use the term rainbows, there's no such thing as mathematical rainbows. I'm just using that analogy so you can see. So I'm going to do 3, what I'll call rainbows here. And I'm going to do those first 3 right away. Now, if there's not a number in front, I'm going to put a number in front so there's no confusion. So I'm multiplying. Here we go. 1 times 1 is 1. And there's not 2 x's. There's 1, 2, 3. When you have the same base, you keep the base and add the exponents. Okay, next up. Negative 5 times 1 is negative 5. And there's 2 x's. 1 times 10 is 10. And there's 1x. Now I've done 3 rainbows. Now I'm going to do like these inverted looking rainbows. 1, 2, and 3. Okay? 1, 2, 3. Negative 5 times 1 is negative 5, and there's an x squared. Negative 5 times negative 5 is 25, and there's 1x. Negative 5 times 10 is negative 50. Now this isn't wrong, but we need to simplify. So the way that I teach students to do it is I start with the first number. None of these other remaining 5 terms have an x cubed. So this is 1x cubed. Okay, done with that. Then I circle the next one. Does anything else have only an x squared? We have one more. Negative 5 combined with negative 5 is negative 10. We don't put x to the 4th. We leave the variable and its exponent exactly the same when we combine by adding or subtracting. So I keep the variable and the exponent, and negative 5 and negative 5 is negative 10. Done. Okay, there's one more like this. Positive 10 and positive 25 is a positive 35x. And last is negative 50. So our second example means to take this quantity and write it down 3 times. 4x plus 3, I'm going to write it down 3 times. And I'm going to underline the first 2. I'm going to forget about this last one, like, just forget that exists right now. And I'm going to FOIL, front, outside, inside, and last. Okay, here we go. Multiplying the fronts, 4 times 4 is 16, and there's 2 x's. Done with the fronts. Now I'm going to do the outsides. Here are the outsides. 3 times 4 is 12, and there's 1x. Done with the outside. Inside, 3 times 4 is 12, and there's 1x. And last, 3 times 3 is 9. Now, out of these 4 terms, these 2, the middle 2, are like terms. So I can combine them. I keep the x, and I add 12 plus 12 is 24. Now, this goes back. I'm going to bring this down to exactly like we did in the previous problem. The previous problem had 2 first, and then we distribute to 3. Now we're going to have 3 here, and we're going to distribute to 2. So I'm going to do 6 rainbows again. So 1, 2, 3, 4, 5, 6. So I'm going to go slowly here. And you have a calculator, so if you think my math is off, just speak up. 16 times 4 is 64. How many x's do I have between these 2? 3. Uh-oh, help me out here. 24 times 4 is 96. How many x's between the 2? 9 times 4 is 36, and there's 1x. Now I'm going to do like that inverted 3 more triangles. I haven't used this, so I'm going to go right here. So 16 times positive 3 is, you're helping me out here, 48. And we have an x squared. 24 times 3 is 72, and we have 1x. 9 times 3 is 27. And just like I did in this previous example, I start by circling the first. No other of the remaining 5 terms has an x cubed, so 64x cubed, done. Now, does anything else have an x squared? Right here. Okay, so 96 and 48. Add those up for me. What do we end up with? Add 4 more. Do we get 144? 144x squared. Is that correct? Can somebody confirm 96 plus 48? Is that correct? Okay, done with those. 36 and 72. Am I at 108? And plus 27. That is our answer.